This is Charlie Heck at the National Science Foundation, co-editor of the Science 360 News Service. An estimated 12 million enslaved Africans were shipped to South America, the Caribbean, and the United States in the largest forced migration in history, the transatlantic slave trade. Spanning the 16th through 19th centuries, records from this period of the Middle Passage are often incomplete. Most focus on vessel and captain names and their home ports, forgetting the millions of humans below deck. NSF-funded researcher Maria Avila, a postdoctoral research fellow in genetics at Stanford University, explains that in this record-keeping, important information has been lost.
It never quite registered the actual origin of this person, not geographical origins or ethnic origins or anything like that. They suddenly became just a number, and a lot of their identity was lost this way, and their history and who they were was lost as soon as they were put in these ships to the Americas.
Avila, with a team of researchers from Stanford and University of Copenhagen, has been able to fill in the gaps through genetics. They recently used an entirely new process to successfully extract and sequence DNA from the skeletons of 3 African-born slaves found on the Caribbean island of St. Martin. Through this, the team was able to discover new information about slave origins that contradicts common beliefs. I spoke with Avila about this newly developed genetic technique. Pretty exciting stuff. You guys have been able to sequence DNA from teeth of 300-year-old skeletons. You want to tell us a little bit about it?
Yeah, it's actually a bit older than 300 years old skeletons. And it's not only that they're 300-year-old, what's impressive is that they were actually in the Caribbean, so it's like hot and humid environment, and that's very bad for DNA preservation. So the fact that we were able to do that is what's really interesting about this project from the methodological part of the project.
Okay, so let's talk a little bit about that. Where exactly were they found, and what are some of the weather conditions like where they were found?
Okay, so these samples, the 3 of them were found in the same site in the town of Philipsburg, which is the capital of the Dutch side of San Martin. That's a Caribbean island. It's a beautiful island in the Caribbean, but it is hot and humid throughout the year. So these were actually found they were renovating one of the streets, and they were doing this construction work, and they came across the samples, and then they had to call the archaeologist in charge, and they stopped all the construction and put the efforts into doing more archaeological studies on this excavation.
Okay, so why does the tropical climate make it a little bit more difficult than, say, a frozen climate?
So one of the novelties of this study is that the first time that we can generate this amount of data, so genome-wide data from samples that were preserved under these conditions, hot and humid conditions. So the studies before, at this level at least, were only done on samples from European context or like Arctic context, even permafrost, but none really on samples from the Caribbean or from these very hot and humid environments. So we were very happy to show that this is actually possible and that it shouldn't be a limitation anymore.
So are you guys using new methods or processes for this specific type of climate?
Yes, actually, that was a key point in the study, is that we use this method that is called whole genome solution capture, so WISC. And this, what it does is it enriches the amount of human DNA in a sample. So, for example, when you extract DNA from a tooth or a bone or even hair, and it's ancient, it will come with some bacterial or microorganism DNA, so environmental DNA, and only a small fraction will be human. So that's what we observed in these samples, and we use this method that was developed here in Carlos Bustamante's group by a postdoc, who's also an author on the paper. So she developed this method where you can basically, it's like building dates that are specific to humans. So what they do is they fish out only human DNA from this pool of human plus environmental DNA. So this way we were able to kind of enrich the amount of human DNA in the sample, even though it was very degraded. We pull out more human DNA, and then we were able to sequence it and have more data as a result of this.
Okay, so going back a little bit more to why this new technique is so important, when we talk about record keeping during the transatlantic slave trade, there really isn't much to go on. So why is this new technique so important, and what do you hope to kind of do with this?
Well, it's very important because, the written record, the historical record from the transatlantic slave trade, it mostly recorded number of people in Africa, embarkation ports, and number of people disembarking in certain ports in the Caribbean or other places in the Americas, Brazil and the States. It never quite registered the actual origin of this person, not geographical origins or ethnic origins or anything like that. They suddenly became just a number, and a lot of their identity was lost this way, and their history and who they were was lost as soon as they were put in these ships to the Americas. So it's very important to us. It's kind of a proof of principle study that we hope it can be expanded, because the results reveal what we were expecting, that the ethnic origins of the first Africans to arrive to the Americas were actually quite diverse. They didn't all come from the exact place where they were embarked in Africa. Their origins actually are more inland, and they were more diverse than some people could think just looking at historical records. So to us it was very important to prove this, that there's a diversity in the first people from Africa to arrive to the Americas.
Okay, so let's talk about these three skeletons. Male, female, do we know an age, where exactly they did come from?
Yes, so these were three skeletons, and there were two males and one female, and they were between 20 and 40 years old. And they had this very characteristic thing in their teeth. So they had certain dental modification patterns that were known to be practiced in Africa, but it's one of the first cultural traditions, in a way, to be lost after the arrival of the slaves to the Americas. So just by looking at these dental patterns, that was the first striking thing that suggested that these individuals were probably born in Africa, just by looking at the teeth, how they were modified. So the archaeologists noticed that, and then they did another study previous to ours where they actually did something called isotope analysis in the teeth. So basically what they do is they compare the patterns of isotopes in the teeth to a worldwide reference panel, and those also pointed to an African origin of these samples. Not with enough resolution to say where in Africa, but at least it was proven this way that the individuals were born in Africa. So, they were in the historical context, etc. They were brought, we knew that they were brought as slaves to this island in the Caribbean.
So specifically, do we know an area in Africa where these three individuals came from?
Yes. So we were able, using a reference panel of modern populations in Africa, we were able to find what populations in this modern reference panel are more similar to our samples. So for one of the samples, for one of the males, we were able to, using what we call nuclear markers, so markers across the genome, and the Y chromosome markers, so that's the chromosome that's inherited from your dad to males only. We were able to trace the origin of this one sample to a place in Cameroon. And he looked very similar to Bamoun, to a population that speaks Bantu today, that is called the Bamoun. So that's the living population that looks more similar to this particular sample, at least in this reference panel we had access to. And the other two samples, the other male and the female, we were able to say they're more similar to populations in Nigeria and Ghana, and these are non-Bantu speakers but similar to Yoruba and Igbo populations that are in Ghana and Nigeria nowadays. So those were our main results in terms of tracing the origins of these three samples.
Okay, so what's next? Are you guys working with other remains, or kind of what do you see happening next now that you have this new technique?
Yes, we actually want to use this technique, and not only in this context. Of course, we want to expand this context, and this work was in collaboration with the University of Copenhagen, and they're world experts on ancient DNA. So together with them, we want to expand our sample size to study more islands in the Caribbean, and maybe some places, ideally also in the States. There's a famous site in New York that it'd be interesting to look at from this perspective, places in Brazil and in Mexico even. And we want to go even a bit further back and not only do it with the African slaves, but also try to identify the original native population in the Caribbean. So these are the Taino population. So now that we trust this method and that we know it works, we can try to even push it a bit more and go further back in time and study remains from the Caribbean, maybe 1,000 years old or older, samples that predate the arrival of the Europeans. So that'd be really interesting to look at as well.
Well, thank you so much for taking the time to chat with us today, Maria.
No, thank you very much. It was a pleasure.
That was Maria Avila, Stanford postdoctoral scholar and co-author of the paper Genome-Wide Ancestry of 17th Century Enslaved Africans from the Caribbean. To read more about this genetic research, check out the March 9th edition of the Proceedings of the National Academy of Sciences. You can also search our top stories on news.science360.gov. The music for this interview is Tempting Secrets, composed by Kevin MacLeod and licensed under Creative Commons. I'm Charlie Heck, co-editor of the Science 360 news service at the NSF.